Okay, so what are we doing today? Oh, Miss Science, we are doing EF, not 4. Oh, so silly. EF-5. So we're doing EF-5, top right-hand corner, and let's hit it. So what have we been talking about? We've been talking about linear and exponential equations and details about exponential equations, okay? I'm going to bring you back to the exponential equation, okay? We have standard form of y equals a parentheses b all raised to the x. What are these things again? So a is your y-intercept. Your y-intercept occurs when x equals 0. What does that mean? Okay, well, if you were on a graph, here is x equals 0, home base, bullseye, right center, okay, smack in the middle. The graph, if it were something like this, I don't know, the graph, wherever it crosses the y-axis, this value is your y-intercept, okay? If you were on a table, it would be right here, okay? So whatever x is, when x is 0, the y value is the thing that's going in your equation, okay? It's that number. The b is what you multiply by. Please notice that I'm saying multiply by, not divide by, okay? It is multiply by. Another important thing, when you are writing the equation of an exponential function, you keep that x there. We fill in values for A and we fill in values for B, and that's all we fill in values for when we're writing the equation. When we're evaluating the equation is another story, but we are only writing the equation today. Okay, so let's jump into it. Which of the following could be the equation of the exponential function shown graphed below? Explain your choice. You went over this with Miss Martin on Friday, okay? How do you know? I don't know. We're going to talk about it. So this function, the first thing you have to do is determine if this thing is increasing or decreasing. We read graphs, we read words, we read everything left to right. So I scan this and I hit my graph for the first time right here. And then I follow the graph. And if this were Miss Lyon's sleigh riding, it looks like she'd be sleigh riding down a nice hill. And notice I said down a nice hill, which means this is going down, aka decreasing. In your equation, how do you know it's decreasing? Well, you know it's decreasing by that number in the parentheses. That number in the parentheses, which is b has to be less than 1 for decreasing, okay? So if I look at this, 1.25, that's bigger than 1, so that's increasing. 1.04, also bigger than 1, increasing, okay? So this one's increasing. This one is also increasing. 0.75 is less than 1, so this one is decreasing. Okay, got it. 0.45 is also decreasing because it's less than 1. Now what do I have to do is determine what the other number means. So this number right here. Oh, that is your y-intercept when x equals 0. So here is my bullseye, x equals 0 right here. I go up, okay, right in this section. I don't really know roughly. I mean, I can kind of get an idea of what this number is, but I can definitely know what it is if I'm looking at these two. So the y-intercept here is between 10 and 20, okay? Well, remember, A, the number attached to the parentheses is your y-intercept. So 40 is attached to my parentheses. 40 is my y-intercept. 40 is not between 10 and 20, so it can't be this one. 18, on the other hand, is between 10 and 20, so it is that one. Bullseye. Why is that? Our explanation. The y-intercept equals 18, which is between 10 and 20. Also, b is less than 1, which indicates decreasing. Oh, yay, perfect. So b is less than 1 and your y-intercept is where it should be. Number 2, same thing. So which of the following is a decreasing exponential function whose y-intercept is 20? Decreasing exponential whose y-intercept is 20. Can I get rid of something right now? I absolutely can. Notice it says exponential. What does an exponential function look like? Well, the exponent is a letter, okay? This exponent is a letter. This exponent is a letter. This exponent is a letter. What about this one? This is y equals mx plus b. Is this exponential? No. This is a linear function, okay? All right, so now let's just figure this out. Decreasing exponential. So we said all of these are exponential, which they are. Decreasing means that b has to be less than 1. 1/3 is less than 1. 1/2 is less than 1. 4/3 is 4/3 less than 1. So 4 divided by 3 is 1.3333333. Notice how it's bigger than 1. So this is not decreasing. This is actually increasing. All right, so now I have this one and this one. These are both decreasing. So this one is talking about y-intercept is 20. Remember where the y-intercept lays. The y-intercept lays right attached to the parentheses. Okay, so attached to the parentheses here is a 1, and I'm plusing 20. So what this does is this just actually shifts the graph up and down. This one right here has a y-intercept of 20 with 1/2, so it's decreasing. So it would be 2. Number 2 is 2. All right, meat and potatoes of today. We're doing a bunch of examples like this. Which of the following functions would best describe the data in the table? The rest of our lesson is going to be talking about how do I determine if something is linear or exponential, and how do I write that equation? And this is what we're going to do, okay? So first things first, I do this every single time. I'm going to circle my y-intercept. Why would you do that? Well, in y equals mx plus b, and in y equals a times b to the x, in both of these equations, you have to know the y-intercept, okay? Y-intercept here is b, where you begin, and a would be the y-intercept section in this equation, okay? So no matter what equation I'm going to use here, I need the y-intercept always. So I'm going to circle that one and make it right in my face so I don't forget it. Next thing I have to do is determine how the numbers are moving on the top and the bottom. So how do I get from 0 to 1, and then 1 to 2, and then 2 to 3, and then 3 to 4? You got it. I'm adding 1 every time. This matters when you are looking for linear functions, okay? So at a constant rate, change in y over change of x. All right. The bottom, well, how is the bottom moving? To determine this, you have to determine if you're adding, subtracting, or multiplying. Notice I did not say dividing. Please notice I did not say dividing. I said adding, subtracting, multiplying. Okay, so the first thing I'm going to do is look at the pattern of these numbers. The numbers seem to be going up, okay? So that means that I'm adding something. I'm adding something each and every time. The two things I'm going to do are look at addition and multiplication, okay? So how do I determine to get from 2 to 8? Basically, what I'm looking to do is determine how many units are from 2 to 8. So I want to know the difference between 10 and 2. So notice I said difference. I'm going to say 10 minus 2 is 8. So that means that if I wanted to go from 2 to 10, I would have to add 8. Okay. I did do subtraction because I wanted to know the difference. Okay. I want to know the difference. Same thing. If I'm multiplying, I'm getting bigger. So that means I want to divide these numbers to get the ratio of how they're getting bigger. So 10 divided by 2 is 5. So that means I'm going to be multiplying by 5 to get to the next number. Okay, so now all we have to do is determine which one of these works for the rest of the numbers on the table. So 2 plus 8 is 10. Okay, yes. Is 10 plus 8 50? It is not. Okay, so that I can cross out. Now let's talk about times 5. 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. 250 times 5 is 1250. So I am multiplying by 5 each and every time. Okay, so since I'm multiplying, I am actually an exponential function because I would only be linear if I were adding or subtracting. So these two are outskis. Okay, so now I have to figure out what actually goes into this equation. I know I'm exponential because I'm multiplying, but what am I doing? So A is the y-intercept. We circled that, okay? It is the y value when x is 0. So the y value when x is 0 is 2, okay? Comes right from here. And then in parentheses, you say, what am I multiplying by? Well, I'm multiplying by 5. And this x comes along for the ride because we're not evaluating. So which one says that? It is number 4. 2 is the y-intercept. What you're multiplying by is 5. All right. Okay. Number 4. 4 has 1, 2, 3, 4, 5, 6. Oh my golly. So for each of the following problems, determine if the table represents a linear function of the form y equals mx plus b or an exponential function of the form y equals a times b to the x. Then write its equation. Okay, we're going to follow the same procedure each and every time. Step 1, is this actually a function? Do I have any repeating x's? So -1, 0, 1, 2, 3. So this is a function, okay? Good. Next step, circle the y-intercept. Okay, there's the y-intercept. I need that whether I'm linear or exponential. Step number 2, determine what your ratio is at the top. So +1, +1, +1, +1. Okay. Because remember, slope is rise over run, change in y over change in x. Next step, determine how the bottom y value numbers are moving. So how am I getting from 4 to 7, and then 7 to 10, and then 10 to 13, and then 13 to 16? You will determine both addition, subtraction, or multiplication, no division. So I noticed that my numbers are getting bigger, so I'm adding something. Okay. What am I adding? What would I be multiplying by? How do you get these ratios? To know what I'm adding, I need to find how many units are between these two numbers. So 7 minus 4 is 3. So that means I would be adding 3. Okay. Well, what would I be multiplying by? Well, to find the ratio, you divide those two numbers. So I would have 7 divide 4, which is 1.75. Okay, so this one would be 7 minus 4, and this one would be 7 divide 4. That's where these two numbers came from. So now let's see what works for the rest of them. So 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. Excellent. So I have plus 3, and I'm not multiplying by anything. So since I'm adding the same amount each and every time, this is a linear function, okay, because I'm adding. Now, the equation. What is the equation? The equation is y equals mx plus b. Okay, well, how do I find m? M is change in y over change in x. Okay, so how did y change? Well, we already found that. Y was adding 3 each and every time. How did x change? I am adding 1 each and every time. So my slope is just 3 because 3 divided by 1 is just 3. So now I have y equals 3x and plus b. Well, b is your y-intercept. We circle it. It's the y value when x is 0. So the y value when x is 0 is 7. Okay, linear y equals 3x plus 7. Excelente. Okay, next one. First, I want to check if it's a function. So 0, 1, 2, 3, 4. No repeating x values. It is a function. Next, I want to circle my y-intercept. My y-intercept happens when x is 0. Now I want to determine how the x's are moving. So how do I get from 0 to 1, 1 to 2, 2 to 3? Okay, so these are plus 1, plus 1, plus 1. Okay, now I want to determine how the bottom are moving. So 2, 6, 18, 54, 162, it's getting bigger. So I'm going to be adding something. So adding something or multiplying by something. Okay, well, what would I be adding by? So 6 minus 2 equals 4. So that means you would be adding 4 each and every time, okay? How would it work if I were multiplying? So 6 divided by 2 equals 3, okay? So that means I would be multiplying by 3 to get to the next term. So let's try it. Let's see what works for these things over here. So I would say 2 plus 4 is 6. 6 plus 4 is 10. Okay, that does not work. It's not plus 4. So let's do multiply by 3. 2 times 3 is 6. Yes. 6 times 3 is 18. Yes. 18 times 3 is 54. Yes. 54 times 3 is 162. Yes. Okay. I am multiplying each and every time. That means I'm exponential. Okay. Exponential functions in the form y equals a times b to the x. A. So y equals, on my line, a is the y-intercept. It is the y value when x is 0. What is your y value when x is 0? X is 0, y is 2. B is what you multiply by. So what did I multiply by each time? I multiplied by 3. Okay. And I raise it to the x power because that is the equation. Next one. Alrighty. First is a function, -2, -1, 0, 1, 2. Yes, no repeating x values. Next thing I'm going to do is circle my y-intercept. There it is. My y-intercept happens when x equals 0. Okay. Now, how are the top numbers moving? So -2 to 1, if I were on a number line, here's -2, here's -1, I would be jumping 1. So these are all moving by 1. Okay. How are the bottom numbers moving? All right. So they're getting smaller. So that means I'm going to be subtracting something, or I'm still multiplying. I'm still multiplying. Okay. How do you know what you're subtracting? Well, you're just finding the difference between these two things. Okay. So I would say 32 minus 16 equals 16. So each and every time I would be subtracting 16. Okay. I know that we're used to saying dividing here, but in our exponential equation, we don't talk about dividing. We talk about multiplying. So we do the same technique for addition and subtraction or whatever. We take the ratio of these two numbers. So I'm going to say 16 divided by 32. Okay, well, that is 1/2. So what's happening here is I'm either subtracting 16 each time or I'm multiplying each number by 1/2. So let's give it a go. 32 minus 16 is 16. 16 minus 16 is not 8. So it's not this thing. Now let's do some multiplication. 32 times 1/2. Okay, 32 times 0.5 is 16. 16 times 0.5 is 8. 8 times 0.5 is 4. Times 0.5 is 2. Okay, so this is multiplying by 1/2 each and every time. Okay, yes, you could say dividing by 2, but in the equation, you cannot put dividing by 2. You have to put what is being multiplied. So since I'm multiplying, this thing is exponential. And my equation for an exponential function is y equals a times b to the x. Okay, so let's write the equation. I get y equals a is the y value of your y-intercept. X equals 0, y is 8. B is what you are multiplying by. What am I multiplying by each and every time? 1/2. Okay, raised to the x power. There is your equation. All right, D, is it a function? Yes. Circle your y-intercept. How are they moving? So +1, +1. This is the same. These are the same numbers almost. Okay. So how am I getting from 32 to 16? Well, we already did this. We said it's either minusing 16 or timesing by 1/2. Okay. So 32 minus 16 is 16. 16 minus 16 is 0. 0 minus 16 is -16, and -16 minus 16 is -32. Okay, so I'm subtracting 16 each and every time. So that means I am linear. Okay, what is the equation of a linear line? Well, we are at y equals mx plus b. Okay, what is the slope? Slope is change in y over change in x. Okay, what is my change in y? Well, we already figured that out. It's how y is changing, so -16. What is the change in x? +1. So your slope is -16. Okay, so you have y equals -16x and plus b. Well, what is b? b is the y value when x is 0. Oh, well, that's 0. So I'm not going to put +0. That would make silly sense. Okay, so I would just have y equals -16x. Last few. Let's see. This one's a little bit of a tricky one. That's why it's on here. This one's an easy peasy one. How about we just go ahead and we're just going to skip this one because there's been a lot of time on this. We will do these last two. So let's do these last two. Okay. So is it a function? 0, 1, 2, 3, 4. Yes. No repeating x values. Circle your y-intercept. All right. There's that one. X equals 0. Your y-intercept is paired with that. How are the numbers moving? So on the top, 0 to 1 is +1, 1 to 2 is +1, 2 to 3 is +1, 3 to 4 is +1. Okay, so what am I doing here? So I need to get from 16 to 20. So I'm noticing 16, 20, 25, the numbers are getting bigger. So that means I'm adding something. Or what am I multiplying by? Okay, I'm adding, or I need to figure out what I'm multiplying by. So what am I adding? Well, that's just the difference between these two numbers. So 20 minus 16 equals 4. So either I'm adding 4, okay, or what am I multiplying by? Well, I have to figure out that ratio. I take the second number and divide it by the first. So I'd have 20 divided by 16. And that gives me 1.25. So what I'm telling you is you are either adding 4 each time or you are multiplying by 1.25. So let's see what works. 16 plus 4 is 20. 20 plus 4 is 25. No. So I am not adding. Okay, let's just confirm these numbers work for us though. So 16 times 1.25. What? Oh, 16 times 1.25 is 20. 20 times 1.25 is 25 times 1.25 is 31.25. 0.25 is 1/4 in fraction form, so times 1.25. Okay, 0.0625 is 1/16. Perfect. We got it. So I'm multiplying each and every time by 1.25. So this is exponential because I'm multiplying. Alrighty, and let's write the equation. So y equals a times b to the x. So that means y equals a is your y-intercept, the y value of your y-intercept, 16. What did we multiply by each and every time? I multiplied by 1.25, and I'm raising it to the x power. I do want you to realize here, so this is greater than 1. That means that these numbers should be increasing. If this were smaller than 1, it would be decreasing, okay? Just a refresher. let's skip that. It's just a linear equation. And let's talk about this last one, okay? So the data in the table below represents either a linear or exponential function. Which of the equations best model this data set? This is exactly what we've been doing this whole entire time. Step 1, is it a function? 1, 2, 3, 4, yes. Step 2, circle your y-intercept. Uh-oh, I don't see it. I don't see when x is 0. I see 1, 2, 3, 4. So what does that mean? It means that we actually have to find it. Okay. We actually are going to have to find the y-intercept here, which is okay because we're going to kill 2 birds with 1 stone, because once we find how these are moving, we can actually find this number. Okay. So across the top, I'm adding 1. And across the bottom, I'm going to have to go from 10 to 20, 20 to 40, 40 to 80. So my numbers are getting bigger. So I'm either adding something, or what am I multiplying by to go this way? Okay. So 10 plus what is 20? 10 plus 10 is 20. Okay. So I would say 20 minus 10 equals 10. The next one, what am I multiplying by? Well, I have to find this ratio. So I'd say 20 divided by 10 is 2. Okay, so that means I would be multiplying by 2. So let's see what works. 10 plus 10 is 20. Plus 10 is 40. No, so it's not this one. So let's do times 2. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. So this is all times 2. Okay, that's excellent. So far, I know that I'm exponential. Okay, so that means I can get rid of these two because these are linear. And what do I have to do now? Okay, well, how would I go backwards to get to this value right here? If I am timesing 2 to get bigger, I have to be dividing by 2 to get smaller. So 80 divide 2 is 40, 40 divide 2 is 20, 20 divide 2 is 10, 10 divide 2 is 5. Okay, so let's fill in our equation. A is the y-intercept. The y-intercept is when x is 0. B is what you're multiplying by. We're multiplying by 2 each time, and you just bring the x along for the ride. So it has to be number 1. I want you to notice what they did here. They said, oh, well, yep, 10, because that's the first number you see. It does not work like that. 10 is not your y-intercept, so we actually had to finish out that little pattern to figure out what we actually had. Okay, so that's that. I hope you have the world's best day in the entire days of days. Bye-bye.